I've moved the speaker now. It's it's right next to a wall, which is it's a plasterboard wall. It's a sort of stud wall partition type of thing. It's not solid brick, but even still, a lot of the base energy is going to reflect off, and we're expecting in this case 6 decibels extra if the waveform that's reflecting is completely coherent, which it probably won't be. So we're not going to really see 6 dB. We'll probably see around about 3 dB of extra bass. But more importantly than that, some frequencies that reflect might come back out of phase depending on the distance from the speaker to the wall. If that's a quarter wavelength, as we've looked at in the theory, by the time it reflects back, it's going to be out of phase by 180 degrees. So we might see some cuts. So let's have a look. I'll just bring us back to the software view. I'll press measure. Quiet on the set, please. There's absolutely loads of cars today. I don't know where everyone's going, but anyway, I think it's good enough. I'm just going to do the same smoothing so we can see. Yeah, there is an increase in the bass, around about I would say just over 3 dB of bass increase. The rest of it's looking pretty much the same. Other things to note is look how much the treble frequency or the higher frequencies are the same, which is just showing you that my original measurement was good. There's a bit of issue here, a bit of a squiggly line, to use a technical phrase. That's because if you look at the room itself, I'm just going to show you, we've actually got loads of crap. There's some cupboards here, and there's the floor. There's lots of stuff lying around which are going to cause phase problems due to reflections. But what we're showing from here is the most interesting thing from this graph is not just this increase, but it's this cut here, which is bang on 200 hertz actually. There's another one there which is on about 280, and then another one there, and another one there, and you got it. It's multiples. It's multiples of the quarter wavelength. So what is the frequency that would be represented? Sorry, what is the wavelength rather of that? So it's quarter wavelength. To work out the wavelength of 200 hertz, we just divide the speed of sound, which is approximately 344 by 200, and we get 1.72. But we're looking for the quarter wavelength, so if we divide it by 4, yeah, so if you place a speaker around about 40 centimeters from a wall, then you will see a cut at 200 hertz. And if you look at the image of the speaker again, you can see that that is, I'm just going to measure it actually just to be sure. Yeah, it's about, from front to back, it's actually about 32 centimeters. But if you think about the way that the wave is going to radiate out spherically from this loudspeaker, then that makes sense. So that's what we're seeing. Okay, we'll have another quick chat about that, and then I'm going to try it with two boundaries.